So number one on the illuminates. Everett's making a concrete path X feet wide around a rectangular fish pond that measures 6 by 12. Which function represents the total area of the path and the fish pond? So this whole big rectangle, essentially, we want the area of. So you would have to come up with a dimension for this, because how do I find area? Good. So I need to come up with an expression for this side. I know that it's 6 feet from like here to here. I know that it's X feet from here to here and X feet from here to here. So it basically becomes 6 plus X, which if you combine like terms, what's X plus X? That would be timesing it. Combine means add, so what's X plus X? I have one X and another X. How many do I have? Okay, so that's what you're doing. With whatever numbers they give you tomorrow, you have to think, okay, X plus X is 2X. You got to make it an expression. The other side, your width, you have to make an expression for as well. You know that from here to here, it's 12. And since it's a rectangular, or it's a X feet wide all the way around, then that means from here to here it's X. And from here to here it's X. So I have X plus 12 plus X, which if you combine like terms, what does this side become? $12 plus 2X. So you got to make it an expression so that we can plug it in and multiply them out. So when you plug it into your area formula, I get 6 plus 2X times 12 plus 2X. And now this is something you've seen before. You guys know how to multiply two binomials. You could FOIL, double distribute, box method. What do you guys like better? They all do the same multiplying, so it's really up to you. I think students in the past have really understood the double distributing really well. So what's 6 times 12? 72. 6 times 2X? 12X. And then I need to distribute this other term that I haven't touched at all. This 2X, I need to now multiply by the whole other parentheses. Table 8, what's 2X times 12?
Correct.
Good. Table 7, what's 2X times 2X?
Twice.
Good, that's not table 7, but I'll take it. All right, 2X times 2X is 4X squared. That's where you get the X squared, you want to multiply. Looking at my answers, I can already tell which one's going to be the right one because only one of them has a 4X squared in it. But ordinarily, yeah, you have to combine your like terms in the middle, the X terms. I do get 36X. And the order doesn't really matter as long as you like keep the signs the same. Like these are all positive. So we're all of these. This one does not. Questions on that? Questions on any others from any study guide? Right? Go ahead. All right, any other questions? Could be from the constructive response even.
Question number 2.
For the illuminate. So number 2. We have a table of values to fill out. They do give us an equation right here. So, and table of values will show up on all of your tests, pretty much. Whatever equation it is, you can see it has variables. It has H and T. And in our table, they're giving us a bunch of T values. all you have to do for these is anywhere that you see a T, you're gonna plug in whatever input they want you to plug in. So like first they want me to plug in a 0. And I would make my life easy and just type this whole thing in the calculator. When I do that, I know I get 24. And then next thing you would do is in your calculator, change the input. What's my next input?
1.
And then you just keep going. I want to say that it's 66 from memory, but again, just use a calculator. I'll let you guys even type in, try the rest. Yeah, have you used that?
Yeah.
Yes. So questions on that? I'll let you guys try the rest of you changing the numbers. Anytime you plug stuff in, use parentheses so that it doesn't become 581 or something weird right here, that it's 58 times 1 squared, and things like that. Other questions? Number 7. So number 7, we have to identify the zeros of this function. Now, we've never done it in this unit where we're identifying the zeros from standard form. So there's really only one way you can do it. By the way, what do zeros mean? Table 2, what are zeros? Or Joel or Cohen? What's another word for zeros? X-intercepts to be specific. So I've not yet taught you how to go from standard form to your zeros. You will learn that next unit. But for right now, all you can do is type this into Desmos. And then identify your zeros, your x-intercepts from there. So you have to know that part, that definition, in order to keep solving. So 6x squared plus 12x minus 48. Okay, and then again, zeros are x-intercepts. See where it touches on your x-axis. Now, on your test, I made it, well, on your study guide, I made it to look just like your test, how they want you to type the answers in. Of course, I'll still go back and check tomorrow when you take your real tests and see if I need to give points back to anyone. But the way that they want you to type your answers is to just put like what the x's are. So here it says x equals and x equals. It'll be x equals -4 and x equals 2. Those are your x-intercepts. Questions on that? Graphing in Desmos can honestly save you if you just know what you're doing. Like you need to know at least some of the vocab to know what you're looking for on your graph, but it's definitely a good resource if you don't know what you're doing tomorrow. Other questions at all? Yes. Number 9. Okay. So number 9. Transformations. So and also what form is this in? What do we call quadratics when they're in that format? Vertex form, good. We learned in a lesson what changing the A, the H, and the K do. And you could memorize that, or since you do have access to Desmos, you could remember what we did in that lesson, which is compared our equation to the parent function. Table 4, what's our parent function? The formula for our parent function? Okay, f of x, and then what? What's the most basic quadratic you could have? So that's our parent function. So if you remember that, then for this question, you could type in your parent function, type in the other equation that they gave you. And I know it from memory because I think it's my third time seeing this today. But type in the equation they gave you. And now you can visually tell me, did it go up, down, left, right? Did it reflect? Did it get stretched? Did it get compressed? So table 5, tell me one of the things it did. Going from the blue to the green. It reflected. Poor connection, hang on, but yes, it definitely reflected. Cause it went from a U shape, like upward to downward. So. Yeah. Hang on. Okay, so it definitely reflected because it is opening different ways, so it had to. Table 6, can you tell me another thing it did when it went from the blue to the green? Well, that's reflected. We'll take something else. Okay, what do we call it? Stretched or compressed when it's thinner? Stretched. So think like if you had a picture on the computer and you were changing the dimensions and you just pulled the top up, whatever was in that picture gets skinnier. So think of it that way. It's a vertical stretch. Table 7, give me another thing that changed about it. It goes up 4. And then table 8, anything else that changed about it? A really good way to tell is to compare the vertex. So it went from 0, 0 to -3, 4. So look what happens if I take this away. Are you guys looking at the screen? Like, so this would be everything that they already said. What is the last change we need to acknowledge? It shifted to the left, how many? Jaden? Yes, 1. All right, but yeah, these are all the changes. So you could memorize it from the lesson, like what changing A does, what changing H does, what changing K does. You can see where all of these are in the equation. Or you could do this, you could graph the parents and graph the transform and compare. So it had to be those 4 different things. Questions on that? Okay, any other questions? All right, going once. Yes. Number 5. Okay, so real life situation going on. We're comparing net worth and years, and it gives you the standard form. You could graph that if you want to see what the graph looks like. That might be helpful. But what you really need to be able to tell me is if I were graphing it, what would have to go on my x-axis? Net worth or years? Of the 2 things being compared, what should go on the x-axis? Years. 1, because it says x years, and 2, because time is almost always on the x. So you have to know that. That'll help you answer the rest, which says The equivalent form reveals that the company's expected net worth is zero after blank years and after blank years. So where on the graph would my net worth be zero? Would it be zero like here? Where would it be zero at? Okay, so like the, right here, right? Okay, so your x-axis is where the net worth is all zero. So when and if you graph it, you don't really need to, if you know how to tell from your factor form. But you would then know that to see where the net worth is zero, I need to be looking at where it touches on the x-axis, my zeros. So again, you could graph it, you can see where it touches. Or if you look at the factor form they give you, you technically don't need to graph it, you should be able to tell just by looking at it. What are my zeros gonna be? From this form.
+4 and +12.
Okay, good. And again, when in doubt, graph it, see where it touches. The only thing that I think you would really need to be able to do is know where the net worth would be zero at. So no net worth goes on the y, zero on the x-axis. So then this answer is 4 and 12. For the next one, it gives you this equivalent form that reveals the company's maximum expected net worth is blank $1 million, which occurs after blank years. Where on my little picture would show me my maximum net worth? The vertex. So you could, again, if you graphed it, just click on the very top and it'll reveal the vertex to you. Or if you look here, you technically don't need to graph it because in vertex form, you should be able to tell me the vertex is 8 and 0.32. But again, you can graph it and see for yourself. So then I need to know what to put here. What of those numbers is for net worth, 8 or the 0.32? So again, think what should go on the X and what should go on the Y. What's going to be the answer for this blank right here? Good, 0.32. Because if this is my vertex, X is for years, Y is for net worth. This is my maximum net worth right here, the 0.32, which occurs when? After 8 years. Okay, so you're identifying the zeros, identifying the vertex, and interpreting it. When in doubt, graph it, see what you can figure out logically speaking. Questions on this one? All right, questions on any others? We have 15 minutes left. If you don't know now today, then you might not know tomorrow. So you should ask now. Or email me or go back and watch all the video recordings I'm doing. All right, last call for any questions? Okay, I'm gonna do the Kahoot then real quick. We still have 15 minutes, so you can absolutely do it. Made to look like your constructor response test, but with different numbers. So what are the y-intercepts of this function, x squared minus 5x? What are the y-intercepts of this function? Right, everyone's required to participate, even if it's only for 10 minutes that we have together. I'm not making you write anything down, so the minimum is just participating. Is anyone still, I think it might just be the rest of the thing? Anyone still trying it? So I knew the answer without graphing it. But you all could have graphed it and then still figured out what the y-intercept is. What does the word y-intercept mean? Where on the graph should I have looked? Where it starts on the y or where it touches the y-axis. I think maybe you guys got confused with x-intercept. Maybe, I'm gonna think. But again, I knew that it was gonna be that without graphing because it's in standard form. And we learned that when it's in standard form, it's really easy to identify your y-intercepts. Your y-intercept is always the c, the constant, and there's no constant here. There's no single number. That means it must be 0. For these quadratics, I've never seen it have more than one y-intercept. So questions on that? All right. Remember on your constructed response, it's not multiple choice, so you write in the answer. What is the vertex of that function? X squared minus 5x. Vertex and y-intercept are different.